When you close an iOS app and reopen it, you expect it to remember exactly where you left off. Snapping right back to that exact state relies entirely on local data storage. Whether it's remembering your layout preferences or keeping your account logged in, every iOS app must store small pieces of critical data right on the device to function smoothly. To pull this off, Apple provides developers with two native APIs, User Settings and Keychain. The choice between them forces a trade-off between execution speed and OS-level security. If you're building your first app and staring down a deadline, you naturally look for the path of least resistance. You want an API you can implement quickly without fighting the compiler. This creates a common trap. It is incredibly tempting to route every piece of local data through user settings because the syntax requires barely a single line of code. Warning tone. Taking that shortcut with user passwords or API authentication keys introduces a severe security vulnerability. Anyone with device access can extract and read those credentials in plain text. To be clear, the choice between these two APIs has nothing to do with file size. Both are strictly engineered for small payloads. You shouldn't be stuffing large images or databases into either of them. The real architectural dilemma is a balancing act. You are weighing the frictionless read and write speed of UserDefaults against the essential protection of the keychain. To get this right, we need a definitive routing framework to map exact data types to their correct storage mechanism. Effective iOS architecture requires weighing the speed of implementation against the specific risk of data exposure. We evaluate these tools across specific vectors, starting with security and encryption. By design, UserDefaults operates with zero default encryption. Data pushed here sits in clean text. Because iOS automatically includes user defaults in standard device backups, this unencrypted data remains vulnerable to simple extraction tools. The keychain offers a much stronger posture, protected with automatic, OS-level encryption by default. This security is backed directly by the device's hardware. Decrypting a payload requires the secure enclave, and access can be strictly gated by biometric checks like Face ID or Touch ID. The second vector we have to examine is data lifecycle and persistence. UserDefaults data has a short lifespan. The very second a user uninstalls your application, every piece of data stored there is permanently wiped from the device. Keychain data survives an uninstall. Because these records are tied to the operating system rather than the app bundle, a secure token will persist on the device even after the host application is removed. This means developers have to manage the data manually. Without explicit cleanup logic, orphaned or stale data can permanently occupy space on the user's phone. While security and persistence dictate safety, developers must also consider the cost of data movement. That brings us to the third operational vector, read-write performance. This is where UserDefaults holds a significant speed advantage. Executing basic strings and booleans happens near instantaneously. If your app handles high-frequency state updates, like saving a scroll position or toggling UI themes during active use, you rely on this efficiency. However, forcing large, heavily nested dictionaries into UserDefaults will cause performance to degrade rapidly, potentially causing the application to stall. The keychain is noticeably slower under similar loads. This delay is caused by computational overhead. On every single read or write cycle, the OS must pause to execute the cryptography required to secure or expose the payload. Our final comparison vector is ecosystem accessibility. UserDefaults utilizes app groups, which allows you to share basic data, like a daily step count, between your main app and its home screen widgets. The keychain uses access groups to allow secure credential sharing across an entire suite of company apps. This enables true single sign-on, where one login unlocks your whole ecosystem. This capability requires complex setup, involving specific provisioning profiles and meticulous management of app entitlements. The performance tax and setup friction reserve the keychain for high-stakes credentials. Let's translate these operational differences into a strict architectural rule. Use UserDefaults for UI settings, and use Keychain for secrets. You can route any incoming data payload to the correct API based entirely on its sensitivity. If the data requires high-frequency updates and carries no security risk, it belongs in UserDefaults. This includes your dark mode toggles, basic user preferences, and non-critical feature flags. If the data is highly sensitive, or if it must survive an app uninstallation, it belongs in the keychain. Use this for API authentication tokens, user passwords, and local encryption keys. If you are an early career or solo developer, the temptation to prioritize implementation speed over security is strong. Do not compromise your users' trust just to save time on the initial setup. Instead of dumping credentials into user data, use Keychain wrapper libraries. They handle the complex APIs for you, making secure storage nearly as simple as writing plain text. For senior developers, the risk is often over-engineering. If your application suffers from UI microstutters, audit your architecture to ensure you aren't bottlenecking harmless state data through the Keychain's encryption process. The optimal iOS architecture leverages both tools in harmony. User dictates how the application feels, while the Keychain protects who the user is.